Hey guys, this is Jackson. Today in this tutorial I'm going to show you how to make a little turret that can fly around. It can teleport, it'll follow the player wherever the player goes, teleporting to different spots in the air, and it'll shoot a barrage of little laser projectiles at the player every so often. Let's just create it. If you want to see what it's going to look like, skip to the end of the video and take a look, but otherwise we're going to get straight into it. So first thing, go to your content browser and let's make a new folder just to keep everything in the one spot, and we'll call this teleporting turret. Crack that open, create a new blueprint class. We'll just call it actor of type actor, and we'll call this teleporting turret BP, and open that up. So I'll just dock that up the top there. The first thing that we'll add is a static mesh, just so this turret thing that is going to be flying around has some sort of body. We can just leave that called static mesh. We'll make that a chamfer cube, just because we'll just keep it simple. You could put a custom mesh in if you wanted, but let's just roll with that. Let's give it like an eye somewhere where it can shoot from. So if we add another static mesh, we might make this glow and stuff later, and we'll call this eye. Compile, save, attach that to the static mesh, and we might just rename the static mesh here to be cube body. And then we have this one called eye. Let's go and change that to a material sphere. Bring that up the front like that. Set it to 50 on the X, because this is a 100 unit cube, so this should be right on the edge. And then if you change the scale of that to 0.25, that'll do. That can be our dude's eye. Alright, awesome. And we should be able to... We can change the material of that to something that makes it look a bit more deadly. But maybe we can get to that after. So let's just chuck this in the world and see how he looks for size. That's a cool size, I think. Yeah, that's fine. So this is our guy that's going to be flying around and shooting at us from that scary ass eye. Okay. So go into the event graph, delete all of this stuff that we've got here. We might create a custom event, and we'll call this activate. And basically you could activate this however you wanted, like you could use pawn sensing to activate this, like when it sees the player or something. But just for our purposes, we're just going to say on begin play, just to test it, we'll say activate. And on activate, this is where we're going to build all our functionality for it to fly around and shoot at us and etc. So let's create the movement first. So go timeline, right click, add timeline, and we'll call this movement timeline. And off of activate, just hook that up to play. And just make this looping, and I don't think we'll need a track at the moment, so let's just compile and save that. Okay, so what we might do off of this is we'll say delay, and the delay just for testing at the moment can just be about 1 second, and each 1 second what we're going to do is we're going to say set actor location, not relative location, we want world location, sorry. Actually no, I think we want, hang on, let me have a look at this. Set actor location. Yeah, set actor location. We don't want relative location, we just want set actor location, because we're setting the location of our entire actor. And the new location that we're going to set it to is going to be some position around our player character. So what we could do is we could right click down here and we can say get player character, like that. We'll say get actor location. So this is the player's location. And then what we might do is we might add to the player's location some random variable, some random vector, so that each time we move to a new location, it'll be some location near the player, but in a different spot relative to the player each time. So to do that, we can right click and we can say random unit vector, and that'll just get a random unit vector of length 1. And then if we multiply that by a float, just for now, we'll promote this to a variable, and we'll call this movement distance from player. Compile so that we can change the default, and let's just change that to like 500 for now. So this will get a random unit vector of length 500 around the player. And then what we want to do Actually, so if we break this random unit vector thing up here, we only want this vector to be above the player. We don't want the turret to be able to get a position below the player. So if we split that, we can drag off of our vector here and we can say make vector. Like that. X will be the same, Y will be the same, random. But then Z, we want to type in ABS for absolute. And that'll make sure that Z's a positive value, like that. Okay. So we're getting a random unit vector with a positive Z of length, whatever distance we've got there. And then we're going to be adding that, go add vector, we're going to add that to the location of the player, just like this. And then we hook that up to new location up here, and we can click teleport. We might as well just have him teleport. And so now, while this is looping, every 1 second, it's going to move to a new location relative to the player. So let's see how that goes. There he is, boom, up there, over there, over there, over there. So that's working. Beautiful. If we wanted to make that smoother, actually no, you know what, let's just leave that like this for now. Yep, that's cool. So what we might do though, is we might make it so that the eye is always facing the player now. Because at the moment he was just teleporting randomly and the rotation wasn't updating. So we could probably collapse this into a function and just call this update position. And that's going to happen every 1 second. But what we could also do is if we make this a sequence here, we can update the position, but we can also continuously update the rotation as well. So if we drag down here and we say set actor rotation, and the rotation that we're going to be setting is, we're going to use the node called find lookat rotation. And the lookat rotation is going to be from our position. So we'll say get actor location of self. And the target position is going to be get actor location, but not of self. It's going to be get player character. So what this whole section here will do, it'll return the rotation required to get from our location to the target player's location, like that. And let's leave that like that, I guess. Let's just collapse it. So we'll collapse view to a function, and this will be update rotation. Just like that. So let's see if that works. Hit play. He's looking at us. He's looking at us. Alright, let's make it a bit slower because he's moving really quick. So we can change this to like 3. Alright, play. Looking. And he's still looking at us. Jeez, that's creepy, isn't it? Oh, fucking hell. What have I created? Where have you gone? Oh, there he is. Oh, there he is there. So we can make it a bit smoother so that we can keep track of where he is a bit easier. So if we're going to update position, this here is basically the new position that we're moving to. So what we might do is if we go back into our event graph, we can expand this here like that. And what we might do is we might add a pin to our little sequence node down here, disconnect that. 2 can be hooked up to update rotation, and then 1 we'll say, oh, we might as well just steal this node from over here. We'll say set actor location like this, put that down here. We can delete our update position function. We're not going to be using that anymore. We're going to create a new one. Actually, we might just create that right now. So if we say collapse function, we can say update location. Sorry if this is getting confusing because I'm kind of going in a circle, but this is going to be a much better system. So update location, basically what we're going to do here is we're going to say lerp vector. So instead of just going cold to the new location, what we're going to do is we're going to set our alpha to 0.5, and we're going to say get actor location. So we're going to get our current location as A, and then as B, we're going to promote this to a variable, and we're going to call this new move to location. Okay, So whenever this update location is called, it's going to move us to the point that's halfway between the new target location, which we're going to set using this, and the position that we're already at. So if we go over here and get a new target location every 3 seconds, so we can promote this up like this, and we can, oops, sorry, not like that. We want to grab this new move to location and set that up here like that, and then hook that up into there. And then we should be able to collapse that to I guess a macro, and we'll say get new move to location. So let me just recap what's going on, because that I don't think I explained that very well as we were going. This is continuously running, so it's going to constantly be updating our location, and it's going to constantly be updating our rotation to look at the player. Now, what it's updating its location to is a value in between where we currently are and the new move to location. And the new move to location is being updated every 3 seconds. So every other frame that we're not getting a new move to location, we're going to be we're moving halfway between the distance of where we are and where we want to be. So that should result in a smooth sliding sort of movement through the air. So if we jump in, where's our... Alright, there he is. And when he moves, see that? See how he kind of... You can see him jump. He's not just cold teleporting, you can kind of see where he's actually moving. And he'll constantly move to some position near the player in that 500 units. Just like that. And he'll always be above the player. He'll never be below. Even if I move up like this, he'll still move relative to us, and he'll never go below where our player is. Cool. Okay, so that's working. That's working well. We could actually promote this to a variable here, and we could call this teleport speed, like that. So we've got a distance from the player, which could be instance editable. Move to location, that won't be instance editable because that's generated in the blueprint. Teleport speed can be instance editable. All of the things that can be instance editable down here, they can all be changed on a tier-to-tier basis, which we'll get to later. So that's good, we've got that going. Now let's build a simple shooting mechanic. So we might just create a simple projectile. So if we go back to our content browser, go blueprint class of type actor, we'll just call this simple projectile BP. We won't set up damage or anything like that because that's just unnecessary for what we're doing here. Let's go static mesh, and we'll just call this sphere, and of type material sphere. Scale can be, I don't know, 0.25, like that. And we'll make this simulate physics, and we'll also make it simulation generates hit events. And let's just say in the blueprint editor down here, if we click on our sphere and if we scroll all the way down to the bottom and we say add on component hit sphere, we can just say destroy actor. Whenever it hits something, it'll just destroy itself, basically. And we might just have like a little emitter or something just so we can see that it's being destroyed. Spawn emitter at location. An explosion, and the location can just be get actor location of self, just like that. Okay, so that's our projectile in the world. If we just hit simulate, he drops and then just gets destroyed. And the explosion appeared in the wrong spot, and the reason for that is we don't actually want the actor location. What we want is we want the sphere location. So we'll get the sphere and we'll say get world location, like that. Beautiful. And that should go like that. Now, we can turn off gravity for this as well, because we don't actually want gravity. So let's say enable gravity is false, and what we'll do instead is we'll set a velocity for this guy in the teleporting turret BP when we launch it. We might add a sound in as well. So we'll just say spawn sound at location. The location is just going to be the same as the explosion, and we'll just use the explosion sound. And we'll pitch shift it, just to make it sound cool. Alright, that's all good. Close that down. We can delete this from the world now. So in our teleporting turret BP, we've got the movement all set up. Actually, what we might do is we might add rotation onto the end of this, just like that. So that's just the movement there. That's getting the new position, this is moving. And now down from this, we'll have another delay. And this one can be shooting speed, I guess. So promote to variable, we'll just call that shoot speed. Compile and save. And the default for that can be, let's say like 2 seconds. So every 2 seconds what we're going to do is we're going to say spawn actor from class. The class that we're going to be spawning is, what was it, simple projectile? Yeah, simple projectile BP. And now we need a transform, we need a spawn point. So if you go back into your viewport, go add new component and type in scene. This is just an empty little component that can just mark a transform for you. So if we say compile and save, that's an error now because we haven't got anything hooked up to the transform, that's fine. So just disconnect that so we can actually see in our viewport what's going on. Now scene should be right on the edge of the eye, just like that. And we might just move that out a little bit, just like that, so that it doesn't overlap with itself. So this is where it's going to spawn. And we might call this projectile spawn point, like that. Okay, so back into the event graph. Drag in your projectile spawn point, drag off, say get world transform, and then just hook that up into spawn transform. So that'll spawn the projectile. Now we just need to set the velocity of our newly spawned projectile. So from the return value, we can say get sphere, which was this here, the thing that's simulating physics. So we'll get that sphere, and then we'll drag off of this and say set linear, set physics linear velocity is what we want. And the velocity that we're going to set to it is we want a unit direction vector, but that is not going to be hooked up to that. I'll explain why in a second. So let's just drag this up here to make a bit of room. We need to get, for the velocity, we need to get a direction from the eye where we're spawning it to the player. So from, what we're going to do is we could just grab this transform from projectile spawn point and we could say break transform, and that can just go into there. So we're getting the direction from the eye, and where we're getting it to is we're going to say get player character, get actor location of the player character, and then hook that up to 2 just like that. So now we've got a unit direction vector. That's only of length 1 though, and we don't want our velocity to have just 1 velocity, a speed of 1. So we multiply that by a float, and this here is going to be called projectile speed. And we can make shoot speed and projectile speed both instance variable. Okay, now the speed of the projectile. I think a good value might be like, I don't know, let's just start with 1000 so it's nice and slow and we can see it, and then we can crank that up later if we want. Okay, so that's this. We could probably just collapse that into a function and just call this spawn projectile. Just like that. Okay, maybe we should have it make a sound when we spawn it as well. So let's just drag off of this and let's say spawn sound at location. The location that we're going to be spawning at, this might get messy, but we'll just put it into there. It's a little bit of crisscross, but it's fine. And the sound will just be collapse, sure. Pitch multiplier, let's just make that like 5 so it's really high pitch. Hopefully it'll sound like a spawning sort of sound. It'll probably sound really ugly, but who cares? Alright, let's jump in. Where you at? Okay, so he spawned a projectile. There we go. Can you see it, that little projectile? The reason that it's so small is because when we got the transform of this scene, I believe that the world transform of the scene is actually 0.25, because this projectile spawn point is parented to the eye, which is parented to this. So what we might want is, we'll disconnect that for now. We can right click this and say split pin. like that. We can also split the pin on the projectile spawning thing, and we can hook up the location to the same, leave rotation as 0, and then leave the scale for this as 1. And then down here we need to hook this up again, so we can say get actually, what do we need? We only need the location, don't we? So what we can do is you can just grab that and just hook that into there like that. Double click this to add a reroute node, and then we can hook that up into, where was it? This, yeah, the sound up there as well, just like that. Spaghetti. Okay, let's see how that goes. Okay, he's shooting at me. There he is. Oh, there he is. Cool. He just shot himself. Cool. So, at the moment, because he's just kind of spawning at random periods, it's a bit weird because he kind of hits himself and stuff. But say you had these like synced up, so you could have teleport speed to be 3, and maybe you could have the shoot speed as 3 as well. So he'll shoot wherever he teleports, whenever he teleports. See that? So he shoots right before he teleports. Wrap this up. Grab your get move to location node, copy that, and up here, hook that up to just after you begin play. Because at the moment what's going on is when this activates, it's waiting however long to get a new move to location, but it's also updating its location already when it doesn't have one. So when you hit begin play, the enemy's going to be sitting at 000 until it actually gets a location, which is a bit sketchy. So if we go in and hit play, straight away he should instantly move to a valid location, just like that. And he's shooting his projectiles just before he teleports. Cool. Now, just one more thing. This is just more of an aesthetic thing. Say we wanted to have different tiers of this enemy, and we wanted a way to... sorry, just delete that. I was going to add something to this video, but I'm too tired, so I can't be bothered. So just as an aesthetic thing, say we wanted to have different tiers of this enemy, and in each different tier we wanted to play around with these values here to make him more difficult or just more different to battle against in game. In your construction script, a way that we can indicate which enemy this is we could change the color of the eye there. This is just something that I'd like to do in my game. So what if we do, off of this we can say create dynamic material instance. Sorry if this starts to get really sloppy because I just suddenly hit a wall and I have no idea why. It's just that time of day. I usually get sleepy about midday. So create dynamic material instance. We'll go and we'll create a new material down in our teleporting turret folder, and this can just be called emissive eye matte, just like that. And this is just going to be a basic emissive that'll just change color depending on the tier of the enemy. So if we hold 3 and left click for a 3 vector, we can right click that and convert that to a parameter, which we'll then call color. Hold M and left click for a multiply. Drag the color into A, and then the output into emissive color, and then we might just have the intensity as like 5, and we won't worry about making that a parameter. Okay, let that save and do its thing. Okay, so double click on parameter, you've color parameter, just to change that to a color to make sure that it's working. Okay, there we go, we've got our eye. So we can close that down. In source material, we can go emissive eye matte, just like that. Compile and save. So if we go to viewport, now you can see this dude's got a little shining red eye. Now, off of return value, we can say set vector parameter value. And off of value down here, we can promote this to a variable and call this eye color, just like that. Super simple. That's all it is, and we can change that to whatever we want. We can make that red, green. Let's make it green, just for now. viewport, compile, save, nothing happened, and that is because the parameter name here needs to be called color, not none. Alright, compile, save, viewport, now we have a green eye. Okay, so now with that done, go down here and make that public, down like that. We can go ahead and create a bunch of different tiers of this guy with different variables. So let's just remove him from the world for now. Click on your teleporting turret like this, go create child blueprint class, leave that the same name, we'll call this child 01, then we can duplicate you, we'll call you child 02, and then duplicate you again and you can be child 03. So these are going to be tiers, tier 1, tier 2, tier 3. So if you highlight all of those, this is how easy it is to make different tiers of similar enemies. It's super easy, as long as you parameterize everything in your blueprints. So this one has an event graph and all that, these ones don't, that's fine. You don't need the full blueprint editor to do this. Just go into, click on teleporting turret thingamabob up the top there, and now under default over here, you'll see all of these variables that we made public. We can change these for this particular tier of the enemy. So let's say if this guy were level 1, like the easiest to beat, we'll say movement is 500. We're not changing that one because that one is determined in the blueprint. Teleport speed 3 seconds, shoot speed can be 3 seconds, projectile speed can be 1000, and eye color we can just make green because green feels relatively safe. So if we close that down now, that's our first tier. Now in our second tier, let's say our movement distance was, let's say this guy gets in closer, like he gets up into your grill. So we'll set that to 400 or maybe even 300 like that. Teleport speed can be 2, so he's faster, and he also shoots faster like that. Projectile speed can also be 2000, so he shoots faster, his projectiles move faster, and the eye color, we can make him yellow, because that kind of feels a little bit more dangerous than green, you know? Okay, now final tier, let's say this guy gets in real close, 100 units, teleports, let's say he still teleports 3 seconds apart, but let's say he shoots at 0.5 seconds apart, so he's just vicious. Projectiles really fast, and let's say this guy's a red color. Okay, these are going to be insane, but especially that last one, but hopefully you can just see how easy it is to parameterize your enemies. So if we put in this guy first, the easy one, hit play. So he's got his little green eye, he's shooting, teleporting around, pretty easy to dodge, not too bad. And then if we were to delete him, put in the other guy, like this. Now he's a bit faster, he gets in closer, he teleports faster, his projectiles move faster, etc. Okay, now if we put in the red one now, this guy's going to be insane and it's going to be really noisy because he's going to be constantly shooting, so I'm just going to turn my volume down. There we go. You get the idea. You could also change the projectile so that the color of the projectile was also the same as the color of the eye. So the way that we do that is, this is in the parent blueprint for that enemy. Down where we've got spawn projectile, crack that open. Off of return value here, what we might do, this is going to get really messy, but that's okay. This is going to get super messy. Let's just drag off that return value and we'll say create. We're going to do just what we did for the eye. So create dynamic material instance of the sphere, like that. The source material is going to be emissive eye mat, and then we're going to drag off of the return value and say set vector parameter value. Parameter name is color. Oops. Color. And the actual color, we're just going to use the eye color of the tier, so down like that. And then if we wanted to, we could collapse that and just say set projectile emissive color, just so we know that what that does. Okay, let's have a look and see if that works. And then I'm going to stop because I am bloody brain dead. So we might as well just chuck them all in. They're shooting coloured projectiles. Looks like it. Beautiful. That sounds hideous. I'm going to get rid of that sound. I really don't like that. Spawn sound. Let's just change you to none for now. None. Goodbye. Cool. So they're all shooting, all doing their thing. One more thing that we could do is this was really obvious with the green one because he had such a wide movement distance. So say we set this to like 1000. So he's constantly getting a distance that's really far from the player. Sometimes he might clip through the walls, like he just might have done. No, he didn't. Alright, that time he definitely clipped through the wall. Right now he's back somewhere, probably, yeah, there he is. So, to prevent him from teleporting to a spot where you can't actually see the player, what we need to do is in the event graph, go to get new location, and up here like this, what we might do, close that down, promote this to expand node, and then we're going to collapse this to a function instead of a macro, and this is going to be called get new move lock, like that. And then we can go ahead and delete the old one, and then we'll need to hook get new move lock up to here as well, because that's where the old macro was as well. Okay, and the reason that we change this to a function is because in a function you're allowed to have a local variable. So if we get rid of that like this, and we promote this up here to a local variable, and we call this test move lock, like that. So here's what's going to happen. The function's going to run, we're going to get a new move location, and then what we're going to do is we're going to run a bunch of checks to check if this is a valid move location before we then go and set the new move location to the one that we've generated here. So we could collapse this like this. Can I collapse that like this? Yeah. And we can say generate a move lock, like that. And then what we can do, I think the best test to probably do would be to do a line trace to make sure that we can see the player from the new location. So say line trace by channel, like that. Drag in test move lock from local variables. That'll be the endpoint. The start point will be that'll be the start point, the new move location, and the endpoint will say get actor location, and the actor that we're getting the location of is the player character, like that. So we're doing a line trace from the new position to the position of the character. The actors that we'll ignore, make array, ignore the player, because if we hit the player that doesn't really matter. If it hits anything else though, we want to know about it. So draw debug type, we'll change that to duration just so we can see where the line's tracing just for debugging. The rest of that's all good. So now off of return value, say branch, so if there's a hit, yes, we want to break the hit, like that. Actually no, we don't want to break the hit. If there's a hit, we can then get a new one. If there's a hit, sorry, not up to there. Jeez man, I am getting tired. If there is a hit, get a new move location like that. And just double click that so we can reroute it so it looks a bit neater. If there is a hit, get a new location. If there is not a hit, then we'll go return node and then hook this up to the return node like that. Close that down, and then out here, new move location, we can just set that to whatever's returned from this, like that. And we'll do the same up here. Okay. So now with any luck, he shouldn't teleport behind any walls. Alright, so he's up there. He's over here. Alright, Alright, so see, he just tried to teleport behind the walls twice, and then he found a new location above us like that. That was valid. And see those green lines again? He tried twice behind the wall, and then found a new location above us that was valid. Okay, so that works. The only problem with this is that if there's no valid locations, it'll crash your game. Because it'll just be an infinite loop. So what you could do, if you really cared, is in get new move location, off of true, you could just make it count to, say, only 10 times. And if it exceeds 10, then just teleport to the invalid location, and just who cares. Alright, that's it. I'm going to log off because I'm done. My brain is about to switch off. So let me know if you've got any questions, if you like this tutorial as well. And I'll try and clarify if there's any problems. If anything I said didn't make sense, then let me know, and I'll let you know how to fix it or whatever. That's it. I'll see you guys in the next one.